Let's go over linear inequalities. You may remember linear equations are, first of all, equations that have an equal sign, and they generally have two variables, such as this: y equals mx plus b. This is the equation of a line. Okay, it's an equation because it has equal sign, and it's linear, not just because it's the equation of a line, but because the variables y and x are to the first degree. So that's what makes it linear. So if we have a linear inequality, it's going to be similar to this, except we're not going to have an equal sign, we're going to have an inequality sign. So we might have y is greater than, could be y is less than, y is greater than or equal, y is less than or equal. And it may not be in this form already solved to represent something similar to the equation of a line. You may have something like this: 3x plus 2y is less than 7. And then solve for y to put it in this form. So in this case, we'd have to get y by itself, we'd subtract 3x from both sides. Be left with 2y. Then we have 7 minus 3x, which is the same as, we just change the order, negative 3x plus 7. Then divide everything by 2 to get y by itself. So if y is less than negative 3 halves x plus 7 halves. So this is an example of a linear inequality. Okay, but what exactly does this mean? To have an inequality sign here rather than an equal sign? Well, it's going to affect the way we graph it, and it's going to affect the possible solutions of this inequality. So let's say we have this inequality: y is less than or equal to 3 halves x plus 1. So again, this looks kind of like the equation of a line, where we have mx plus b, where 3 halves is the slope and 1 is the y-intercept. So let's graph it as if this were a line. So we have y-intercept of 1 and a slope of 3 halves. So it's going to pass through this point in 0, 1. It's going to go up 3, 1, 2, 3, and over 2. Something like this. So this is just a sketch. Say it looks something like that. Okay, but we don't just have y equals 3 halves x plus 1. It's y is less than or equal to 3 halves x plus 1. So that means that we want y values below this line, because y has to be less than this. So the solution would be anything under this line, so anything in this area that I'm shading in here, so anything here, in addition to any point on the line, because y can equal this this line. Y can equal 3 halves x plus 1. So anything here or on this line is a solution to this inequality. Okay, what if we had a different inequality, such as y is greater than negative 2/3 x plus 3. Okay, I'm just going to graph this with a different color. So y is greater than negative 2/3 x plus 3. So that means the y-intercept is 3. Then it has a slope of negative 2/3, so down 2 and over 3. So if I was going to sketch this, it would look something like this. Just this part, if it was a regular line, negative 2/3 x plus 3. But we have a difference here. Okay, first thing to note is that in this inequality, y is less than or equal to 3/2 x. So the solution could be on this line. In this inequality, y is greater than negative 2/3 x plus 3. But there's no line here to represent that it can equal it. So because the solution can't be on this line, we have to make this a dotted line. So I'm just going to change this to a dotted line or a dashed line. So we know that the solution can't exist on here. Alright, but it doesn't take care of everything, because the solution can also be greater than this point. So it could be anything above this as well. So we have to shade upward. So if we were given both of these inequalities and we had to solve for the system of them, in other words, a value or a point that satisfies both of these inequalities, we would just look to see where they overlap. So in this area, we have an overlap. So this area would satisfy both of these inequalities. So if the question was to identify a point that satisfies both of them, we could pick any point in this area. So for example, we could pick this point 1, 2, 3, 4, 5, 6. 6, 2 would be a solution, but this entire area we can mark with an S to show that this entire area is the solution to these inequalities. And this is just an example of one point that would satisfy both of these.